Let me do this. So week 1, Trig. Week 2, we're also doing Trig. Just want to highlight that on Thursday, I'm not going to be here. Miss Yama will be here. We're going to do attendance, and you'll have async learning if you need to. More on that later. Next week and the week after, we're going to do CAS prep, and then week 5 will be the CAS test. We'll talk about why it's important, what's interesting about it, all the things. And then week 6 through 8, we're going to do PT and ACT. So super, super cool. And then we're going to go on summer. It's going to fly, friends. Anybody have any questions about the schedule? I'm about to talk about Thursday. Lots of nugget talk in the chat. Great. Dino nugs. All right. And Sada E, yes, you totally can. All right, so for Thursday, I can't be here, but Miss Yama will be here to hang out with you. She will also give you the attendance on Thursday. Speaking of, Galdi, can you put the attendance in the chat, please? So here's the deal. In Canvas, everything's actually posted for Thursday already. So you can, all the stuff is there for today as well as for Thursday. You're gonna watch the notes or watch the video. The notes will be in Canvas. They were not emailed to you. That's a lie. They weren't emailed to you last night, but they are in Canvas. And then you're gonna complete assignment 36 on Thursday. And you'll have 3 options for where you can do it on Thursday. You can do it in your breakout rooms if you want. You can do it you can stay and work in the main room with Ms. Yama if you want. Or on Thursday, you can take attendance and then log off. Okay, so all of this is for Thursday if you need to. Are there any questions about Thursday? So I won't be here, but you'll still be expected to do your notes and your assignment. Ms. Yama will be here to support. Okay. Cool. And then just wanted to highlight for office hours. We know that there are some times when you need office hours or you have questions or you just want to whatever. I just wanted to, we've gone back and forth on a few times. There still will be office hours during the week, but I think it's easiest, honestly, if you just message or email me or Ms. Yama, and then we can set up an individual time with you. So totally open to that. If you have a small group of people who wants to work together and you all have the same question, you can all come. Just let us know when we can be the most helpful to you, and we shall do that. Cool. All right, that's the end of our announcements. Anybody got any questions about announcements? Kimberly, I'm actually seeing this now. Kimbo, there are technically 9 weeks, but that last week's going to be post ACT and awards. And so there's really only 8 weeks of class, true class. I'm sure we'll have some kind of class in week 9, but it will be less than 10. Yeah, but there's definitely not 11. Quarter 3 had 11. So normally it'd be 10 and 10, but this one's 11 and 9. And the last week doesn't really, it counts, but it's going to be different. So I don't want to put it on there. Good question. Cool. Okay, team, let us jump into our notes. Tell me, based on your timing, tell me what your timing is. Are you ready to go? Do you need a moment? Do you have paper or pencil? You got the notes out? I'm going to switch my screen. New share, AirPlay. So that I can take some notes with you. Oops, just accidentally turned on my TV. Okay, there we go. Not that one, this one. All right. Cool, looks like 8 of us need a little extra time, so we'll take that. Do a morning stretch if you haven't stretched this morning. Just a reminder, your body needs to be stretched, even if you haven't, even if you've been awake for a long time. Awesome. All right, team, let us jump in. All right. If you still are out and about, no worries. Just jump in when you're ready. If you are someone who would like to jump into a breakout room, now is an appropriate time to jump into a breakout room if you prefer to watch the video, if your Wi-Fi is on the fritz or whatnot. Let me know if you can't see your breakout room. You can message me and I can move you around in the breakout. All right, today we are going to build off of what we know from last week with Trig identities. And today we are going to verify Trig identities, right? So verifying is our like new vocabulary. And we're gonna learn about what it means in the math context. So so last week we learned about like tangent is sine over cosine. Do y'all remember this? Secant is, what's secant? Somebody put it in the chat or come off mute. What's the fraction for secant? Let's just review these real fast.
Is 1 over cosine x.
Yes, 1 over cosine, for sure. Thanks, Diana. What about cosecant? What is cosecant?
One over sine x.
1 over sine, right? And then cotangent, what's the one for cotangent? The reciprocal of tangent.
Cosine x over sine x.
Yes, cosine over sine. Diana, you're the MVP of this one, of this section. Thank you. Okay, so we have these ones that we have like sort of floating around in our brain. Today we're going to learn 3 more. We're really going to focus on 1. Okay, so one of the things that we already know is these are called the Pythagorean identities. The identities here are sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. These 3 things are super important. I would say if you're going to memorize one, this is the one to memorize. I have seen that come up on most ACTs. Like I think basically every ACT has this in some format. And it's about the only pre-calculus that exists on the test. It's almost always, if there's a pre-calculus question, it's almost always related to this identity here. Right? So super important one. I want to show you just quickly where these came from. If this is helpful for you to write it down, feel free. If it's not helpful, then just watch. So Pythagorean theorem, Pythagorean identities, like a squared plus b squared equals c squared, right? Remember we created the like quote new version, the like adult version. So x squared plus y squared equals r squared. If you manipulate this by dividing everything by r squared, right, what happens? R squared divided by r squared, that's going to be equal to 1. X over r, y'all remember like sine is y over r, cosine is x over r, right? Tangent is y over x. X over r is cosine. And since it's squared, we basically have cosine squared, and you can put in the variable we're choosing, I'll use x here, plus y over r is sine, and it's squared, I use x here. Y'all see that with just like one quick step, we can go from Pythagorean theorem into this identity here. It's kind of like, whoa, crazy. So this dividing by r squared is how we get our first and most important identity. The same is true if you divide by other things, right? So if we divide by x here, we divide by x squared, x over x is 1, y over x is tangent, and it's squared. and r over x. Remember, that's like the flipped version of cosine, which is secant. Secant squared. That's how we get this one. Interesting. And then over here, if you can imagine, we're going to divide by y squared. If we divide by y squared, x over y is cotangent squared plus 1 equals, and then r over y is cosecant squared. That's how we get this one. You'll notice they're out of order, right? We can switch, remember we can switch things when they're addition and subtraction. But in general, the Pythagorean theorem is how we come up with these three identities here. That's why they're called Pythagorean identities. Okay. Are there any questions about these three items here? Okay, something to note about this one. It's not always written like this. Sometimes what people might do instead is they might say, okay, I'm going to subtract cosine squared on both sides. And they'll say, okay, the identity is sine squared x equals 1 minus cosine squared. They can have something like that. You can also move sine over, right? So you could also say, instead of moving that, you can move sine squared. So you could say cosine squared x equals 1 minus sine squared. Right, so we're gonna start to recognize those things as we do our problems today. So the basic strategy is going to remain the same as last week, right? The basic strategy is to simplify the more complicated side to see if it's the same as the other. So to verify something means to check if something is true, right? To check if it is true. So you'll see in these problems here, you'll see that we have something on the left is equal to something on the right. So when our directions say verify, right, we are checking to see if tangent theta times cotangent theta is equal to 1. We're checking to see if the left side, this fraction, is equal to the right side, cosine. We're checking to see if the left side is equal to the right side. So the strategy we're going to use is we're going to simplify the more complicated side to see if it equals the other side. Okay. Are there any questions before we see some examples? All right, well, let's try verifying A. So first I'm going to identify what's the more complicated side. I think tangent and cotangent, more complicated than 1. So I'm going to leave 1 alone for now. My goal is that I can get equals 1 at the end, right? That's my goal. I want the 1 to just come straight down and be 1. Okay. What can I term tangent into? Diana helps remind us. What is tangent?
Y over x.
Sorry, Diana, I think we missed you there for a second. Want to try again?
Yes. It's y over x. My bad.
It's y over x, yes. Instead of y over x, I want us to use like sine and cosine, like this one up here.
Oh, it's sine x over cosine x.
Yes, perfect. Right. Thank you for reminding me of that. Sine over cosine. Wow, the lag is brutal today. All right, sine over cosine. You can put x here if you want to. You can put theta there if you want to. In this case, I guess it is theta, since there is theta in the question. Do you see how like it gets a little sloppy though? That's why I usually use x or just nothing, to be honest. All right, so sine over cosine. What is cotangent? What can we turn cotangent into?
Cosine over sine.
Cosine over sine. So we'll notice here, all right, sine divided by sine would be 1. Cosine divided by cosine would be 1. So we get 1 as our answer here, right? each piece has divided. We're going to say, okay, it's supposed to be equal to 1. Is 1 equal to 1?
Yes.
Yeah, it is. 1 is equal to 1. So we can say, yes, this is verified. Right? This is verified. So when we're verifying something, the answer is like a number equals that same number, or like cosine equals cosine. Our goal is to have the same thing at the end. Okay. Awesome. Thanks, Diana and Gally. All right, let's look at B. Take a moment to write down B. 1 minus cosine squared over cosine. Which would you say is the more complicated side, left or right? Which is the more complicated side? Yeah, I think probably left. Yeah, I think left too. Okay, everybody agreed left. So we're gonna leave this side alone, right? We're gonna leave cosine theta alone. We're gonna try to simplify the left side, right? 1 minus sine squared theta. So I see that squared, so I'm thinking, okay, which of these has squared in it? It would be this one here, right? Our most important one. If I do 1 minus sine squared, right? 1 minus sine squared is equal to cosine squared x. So I can take out this portion here and I can replace it with cosine squared. I'll use theta in this case. So I'm taking out the 1 minus sine squared. I'm saying that's the same as cosine squared. And it is over cosine theta. How can I simplify cosine squared over cosine? How can I simplify cosine squared over cosine? Any ideas? Yeah, it would turn into just cosine over 1. Here's how. Cosine squared is just cosine times cosine, right? On the top. And then on the bottom would be cosine like that. 1 cosine and 1 cosine is going to divide to equal 1. And we'd just be left with cosine theta, that's this one here, equals, pulling down this one, cosine theta. So we can see that this is verified. So our big strategy is just to leave this one alone as long as possible and to see if they are the same. Can you repeat how you got cosine squared on the numerator? Yes. So cosine squared, I converted 1 minus sine squared theta into cosine squared because we know that sine squared plus cosine squared equals 1. If I want 1 minus sine squared, I can subtract sine squared on both sides. And that's going to give me cosine squared equals 1 minus sine squared. So since I have 1 minus sine squared here, I can convert that into cosine squared. Yeah, I know, whoa, right, Galilee? Pretty cool. You're welcome, Jimmy. So that's how I moved from the yellow portion here to the yellow portion there. All right, based on these 2 examples, how are we feeling? Just based on these 2, you might be like, is it about to get harder, miss? I might be like, yeah, but I want to know where we're at. Okay. Some 2s, 3s, 4s. Largely 3s at this point. Thank you for letting me know. All right, awesome. Let's go ahead and write down this one. For C, would you say, which would you say is the more complicated side, left or right? Which would you say is more complicated, left or right? This is a difference of opinion. You could try to do something with each side. But it looks like left to me is more complicated. It has like these parentheses here. We have just sine and cosine over there. Not much I could do with sine and cosine. So I'm going to work with the left side here. Using the exact same thing from before, what does 1 minus sine squared equal? What can I simplify that to? Cosine squared, yeah. Cosine squared. So I have tangent theta times cosine squared theta. What can I turn tangent into? Sine over cosine, yes. Times. I'm going to just write cosine as two of them, cosine times cosine. Since it is cosine squared, I'm writing cosine times cosine. What, if anything, can be simplified here? One of the cosines, yep, one on top, one on bottom, can divide to one, cosine over cosine. So I would get sine theta from this one, cosine theta from this one, equals, check it out, equals sine theta times cosine theta. Dun, 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 dun. Dun, 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 dun. Yeah, we've been played, I know. Okay, yeah, if you're having trouble with this like first section here, not trouble, just like you asked that question. We have sine squared plus cosine squared equals 1. That's like an identity. That's one of the new identities that we're learning today, right? One of the new identities. If I want to know if I have 1 minus sine squared, if I subtract the sine squared to the other side, I'm left with cosine squared equals 1 minus sine squared. So I know that 1 minus sine squared is the same as cosine squared. So I can replace them as necessary. They're equal to each other. Yeah, right? You're welcome. Okay. So we have verified. All right, let me relaunch this. I think maybe we might have felt a little better after that one. How are we feeling now? Based on A, B, and C, how are we feeling? All right, nice. Looks like we're feeling a little bit better, more 4s this time, which is great. Some still 2s and 3s, no problem. Some 5s, awesome. If you're feeling like a 5, really dig in here. All right, which of these looks like the more complicated side, the left side or the right side? Which of these looks more complicated, the left side or the right side? Gali says 1 vote for the right side. Mia says 1 vote for the left side. Yeah, I mean, the fraction for me makes that look more complicated. You might think like, oh, it's so simple on the right, but like maybe that makes it complicated. Diana's like, both make it complicated? Yeah, I don't know. So here's my first thought. Okay, I see a fraction. I'm going to try to simplify the fraction. Cosine squared theta, I know that that's the same as 1 minus sine squared, but I might be like, okay, don't write this down. Don't write this down. I'm just thinking through something. 1 minus sine squared, I can turn cosine squared into 1 minus sine squared, and then I would have 1 minus sine theta on the bottom. Can I cancel? Think really deeply here. Can I cancel the 1? Am I allowed to do that? No. Don't kill cats. I used to say this thing, like when you do this, you kill a kitten. It's very sad. Just don't do that. You cannot do it. Why not? Why can we not cancel the 1? It is negative sign, but that's not the reason why we can't cancel the 1s. Let me ask you this. 1 plus 10 over 1 plus 9. Does that equal 9 over 10? No, it doesn't, right? 9/10 doesn't, like 9, think about what you would be saying. You'd be saying 9/10 is equal to 11 over 10. That's just not true. They're not, right? It's a pack, yeah. They're tied together by plus and minus. Anytime you have plus and minus, you cannot like cancel them. It's different from multiplication. When there's multiplication, you totally can cancel them, right? No problem when there's multiplication. But if you have addition, they are tied together to come together. All right, so I have this thing here. I can turn cosine squared into squared here. I can't cancel sine either because of that minus there. So here's what this is what I'm teaching you in this problem. What I could do is move the denominator to the other side by multiplying. So here, I'm going to erase literally everything on here. All right, I am going to multiply 1 minus sine theta to the other side, 1 minus sine theta. That is going to cancel, because it's multiplication, and leave me with cosine squared theta on the left side. The left side just became less complicated. The right side, however, just became very complicated, right? This is how I'm going to deal with this very complicated piece. This is some magic. Ready? Check out the box. You're like, Miss, what? The box? 1 plus sine theta. 1 minus sine theta. Okay, what's 1 times 1?
1.
Yes, great. Thank you, team. What's 1 times sine theta?
1 sine theta.
1 sine theta. I'm just going to write sine theta. What's 1 times negative sine theta?
Negative sine theta.
Negative sine theta. And what's sine theta times negative sine theta?
Negative sine theta squared.
Yes, negative sine squared theta. Those things are the same. I can put the square. I'm going to put the square on sine. All right, so check this out, y'all. When I multiply these together, I get 1. Sine theta and negative sine theta cancel each other out. And I have negative sine squared theta, 1. So this equals 1 minus sine squared theta. What? So I took this, I put it in the box spit out this. Do y'all remember that this is one of our like identities? We have cosine squared plus sine. Go, Diana, what's up?
I was gonna say that one is like cosine squared.
Yeah, that is like cosine squared, right? Because if we move the sine squared over here, we have minus sine squared. So we have cosine equals 1 minus sine squared. So we have cosine squared theta equals cosine squared theta. Your minds are like, mind blowing, right? Why does it keep working? I know, Galilee. Why does it keep working? But it does. It's wild. Okay, so the lesson of this one here is that if there's nothing you can do to like simplify one of the sides, if it's a denominator, you can move it to the other side. You can make it a multiplier. I know, pretty wild. So that's what we did here. This first step, we did this part and that put that over here. And that's what sent us to the box. I know, wild. Mind blowing, but pretty cool. All right, let's do one more. Let's do this one here. All right, I gotta be honest. This might blow your mind again. I know, in a good way. All right, I'm looking here. This is definitely more complicated, the left side. Your mind is boggled, I know. Just keep letting your mind be boggled. It's okay. You're learning. That's how we're learning. We're stretching our brain in a new way today. All right. So I'm going to start with the left side here. Cosine theta, can't do anything with that. Sine theta, can't do anything with that. Tangent, I can do with that. Okay, so I have sine theta times sine over cosine. All right, so I have sine squared theta over cosine theta. And then I have over here cosine theta plus. Am I allowed to just say, okay, cosine theta plus sine squared theta over cosine theta? Am I allowed to do that? Can I just combine them like that? No, why not? I can't do this, why not? It's addition, yeah, it's addition. In order to be able to add these, what do they have to have? In order to add fractions, what do they have to have? Same denominator, yes, same denominator. So I'm gonna make this one, the cosine theta, have a denominator of this by multiplying. I'm gonna use by multiplying times cosine theta over cosine theta. So now I have cosine theta times cosine theta. So I'm gonna have cosine squared theta over cosine theta. So this becomes one big fraction plus sine squared over cosine theta. Do they have the same denominator now? Yes, they do. So now I can write cosine squared plus sine squared over cosine. And this is that identity. This is that identity. What does cosine squared plus sine squared equal? I see cosine squared plus sine squared. I think 1, yes, 1 over cosine squared. I'm sorry, cosine theta. Why do we do that? Why do we only do it to that term multiplied by cosine? Right here, Devin, I am multiplying times technically like 1. Cosine over cosine is 1. What I'm doing is basically the equivalent of like if I had 2 plus 3/4 or something, I would multiply this by 4 over 4, right? So then I get 8 over 4 plus 3 over 4. That's essentially what I'm doing. I don't touch the 3 over 4. So I'm not touching this part here. Yeah, good idea. Okay, so 1 over cosine. What is 1 over cosine? How can we simplify 1 over cosine? Secant theta equals secant theta. Check it, y'all. Verified. What? You're like, this is some sort of witchcraft. Yeah, it is kind of, it feels like it, right? It feels like magic. Feels like magic. It's not magic, it's math. Math magic. Yeah. Oh, I never ended this poem, my bad. What the heck? Math is crazy. I know, right? Y'all, what a great lesson that we're learning today. Math magic. All right. So verifying, the big thing that we learned today is that verifying is just making sure that one side equals the other side. Wait, see, wouldn't you multiply the other side? Brandon, tell me more. I don't know what that question means. Why don't you multiply which side? Are you talking about this cosine section here? Yeah. So in this problem here, when we had what we had in purple here was basically like, I'm going to put it in just numbers form, 2 plus 3 over 4, right? I have a whole number plus a fraction, and I want to be able to add them together. In order to do that, I would need to multiply times some number like 4 over 4. I need to multiply by some version of 1 so that they have the same denominator. So I would have, okay, 2 is actually 8 over 4, and I'm adding the 3/4. I don't actually do anything to the 3/4. So I'm just, when I do cosine over cosine, this is a version of 1 that is helpful to me so that I can have cosine on the bottom so that then I can add them together. The other side, like the secant. Oh, no, I don't, like, if you're thinking what I do on one side, I have to do on the other. No, I don't have to do it on the other side because this is just multiplying times 1. So I could do on this side, I could say, okay, I have secant theta times cosine over cosine. But then when I get down here, I would have secant times cosine over cosine, and I would just cancel these to get back to secant. I could do it, but it's not going to change my problem at all. Yeah, because cosine over cosine is just 1. It's going to divide away. You're welcome. If we have 1 on the homework, like the third one, we have an identity on the bottom, do we just multiply it out? This one ended like this, like C, 7, D. When you get to this location where you're starting to see the identity, then you want to just take it one step further. So you have like something equals something. Devin, let's hold off for just a second. I want to wrap class, but I want to answer your question. So team, for today, you are putting your notes in here. You are answering 8 questions. So if you get stuck on one, skip it, try a different one. I'm going to call this choose 8 attempts. I want you to attempt 8 problems. If you don't get the answer, that is okay, right? That is okay. We are just trying and wrapping our brain around these questions. So you have 8 questions out of 1 through 10 for you here. You have the chance to write and solve your own if you want. You can make it as easy or as hard as you want. You're going to put these questions here. And then finally for part 2, that we're just continuing to practice assignment 33 because it's going to come back for us on Thursday. It's going to wrap into a nice pretty little bow on Thursday. Okay. There is extra credit ACT if you would like it. You're welcome to it. But other than that, that is your assignment for today. So 10 problems. In the beginning ones, you're just simplifying. Notice there's not something to verify with. You're just simplifying this into something that looks like one of the blue answers here. For numbers 5 through 10, that's when you actually have 2 sides of the equation and you're going to do some math magic. This is your magic section. Okay. Any questions about the assignment before I go back to Devin's question? Cool. Okay, if you need to jet, feel free to jet. And I will see you next week, but we'll have class on Thursday. I won't be here. And then on Tuesday of next week, I'll see you again. Okay, friends. Bye. Have a great day. Have a great day. Devin, can you tell me more of what you're thinking about for D, what your question is?
So you know how like when you first look at it, you see cosine squared theta over 1 minus sine theta.
Mm-hmm.
If we see that like just in general, like on a problem, it's a good thumb rule just to like multiply out the bottom. If that makes sense.
Yeah.
Is that like a good like a good way to start?
Yeah, I think if you see like, oh, there's like really not like, if I think what your question is like, if I see this and there's just like, I know that there's really nothing I can do, then can I just jump to the multiplication part? Yeah. So then, yeah, you totally can. So like in this case, I'm like, that's not really that helpful. I mean, one thing you could have done, Devin, something we could have done, cosine squared theta is just the same as 1 minus sine squared theta. So if you wanted to jump from like this to this, you could have, and then you would have been done here, right? Would have been done like one step earlier. But like, I don't know. There's not much you could do here. So you might as well just jump to the 1 minus sine theta, like that. Did that answer your question? There are many different directions you can go, right? So they're like, this is not the only way to do it. It's just the way that I came to. Cool. Okay. I'm glad, Devin. Sounds good. Yeah, you're welcome, Nathan. Yeah, Sada E, you want to work on 9?
Yes, please.
Okay, let's see. Number 9. All right. Tell me, have you done anything? Have you gotten somewhere, tried something and got stuck? What's up?
Okay, so when I was doing it for cotangent, is it
Uh-huh.
cotangent? I got
Yeah.
cos over
Theta. Mhm.
theta sine theta.
Yeah. So you
Yeah.
turn cotangent into this fraction here.
Yeah.
And then it's over, what's
Over
secant?
secant, and then secant, I changed it. I think this is like it. I changed it to 1 over cosine.
1 over cosine, perfect.
And then I multiplied them by flipped cosine and 1.
Yes. So this flips over, right? So you
Yeah.
would have basically cosine over sine, that's the green one, times cosine over 1.
And I don't know if I was supposed to do this, but I combined cosine and cosine.
Okay. So you got cosine squared
Mhm.
over
Sine.
over sine.
Okay. That's what I got.
Okay.
And then what I was trying to do, I was trying to convert the cosecant and sine to fraction as well.
Okay, let's try that. What do you got on that one?
I got 1 over sine.
Perfect.
And then then it's sine, negative sine over 1.
Yes.
Mhm.
Okay, so in order to put these together,
Mhm.
they have to have a common denominator.
Yes.
Okay, so what can I multiply? So this one I need to be sine, right? The 1 needs to be
Yeah.
sine. So what can I multiply by?
Can you multiply by the sine on the other side? So
Well, oh, like you're saying this sign over here? Oh, that's a good idea, Sarah. You could do that, yeah. My thought here is that I can do this times sine over sine.
Okay.
So that I can make a common denominator just on the right side, just the blue and yellow section.
Okay.
Do you want to, can I show you my way and then we can look about how, is that okay?
Yeah, that's okay.
Okay, so we have sine times sine would be sine squared over sine. Does it make sense, Sarai, like why we have to do, or like why I'm allowed to do this portion, the yellow?
Because you have sine on the other side, right? No?
Yeah, it's not just because I have sine on the other side. If this side didn't exist, I could still do sine over sine. It's like it's like I have, let's say I had like 1/2 minus 2. If I did this part, the yellow part is like doing this part where I do like over 2 like that, so that I can get it with a common denominator.
Okay.
Do you know what I mean? Like when we're working with fractions?
Yeah.
Okay.
You have to
So
them out.
yeah, yes,
Mhm.
exactly. So now I have the 1 over sine. You see how now I have sine theta on the bottom for both of these?
Mm-hmm.
So
then
now I have, go ahead.
now you have to cancel out the sign, but you're still gonna be left with one sign on the other side.
Okay, good idea. Here's my thought. I just did all of this hard work so that I have the same denominator here. So I'm gonna combine it into one fraction, 1 minus sine squared over sine.
Okay.
What do you notice about one? What can I change 1 minus sine squared into?
That could be changed into cosine.
Cosine squared, right?
Yes.
Cosine
Oh.
squared theta. Isn't that magical?
I saw it now. Okay.
It's magic, isn't it magic?
Yeah. Okay, cosine. Oh, okay, I understand that.
Okay, here's my thought. I want to go back to your original idea. Slash, do you have Spanish right now?
I do.
Okay, let me do this really fast then. Sorry, Miss Bobadilla. Okay, so remember when you had you solved all of this and you got to cosine squared theta over sine squared. Do you remember that?
Yes.
And then on the other side, you were like, okay, I have 1 over sine theta minus sine, minus sine. Come on, computer. There we go. What is its deal today? Hello, let me draw. There we go. Sine theta like this. Okay, you had this portion, and remember you told me, oh, let's multiply the sine on both sides?
Yes.
Okay, watch what would happen if I had done that. Let's say I multiply sine theta over here, cancel, cancel, right? Over here, I multiply sine theta. Now this goes on there and this goes on here. So now
then
on
one
this
sign
side,
would be,
go ahead.
so one sign would be to the power of 2.
This part right here would be sine theta over sine theta minus, and this part here would be sine squared theta, like that, right?
Okay. Yeah.
And then sine over sine, what does this equal?
1.
1 minus sine squared theta equals cosine squared theta. Is that true?
Yeah.
And this right here is cosine squared, right?
Mm-hmm.
Cosine squared equals cosine squared. Same.
Okay, so it could work like that as well.
It totally could have worked. That's why I wanted to show you. I just wasn't sure that we were like prepared for the distributing of the sign. And so that's why I didn't want you to like go into this rabbit hole.
Okay.
But you can, it will work. Like math is awesome. You can do it 100 different ways. But now we have 2 ways. The way that you and I did it together, that's like making a common denominator, which can be hard too, but something that we practice a little more so we get this answer. Or this one here, if we distribute in that sign like you wanted to, we can still get this, we can still verify that they are correct.
Okay. Thank you, Miss.
You're welcome. Great job. Enjoy Spanish.
Very smart way, by the way.
Thank you.
Good job.
Good job. Bye.
You're